I find these are the problems that students struggle with the most. Solving this inequality, we've got to make sure we add 2 to both sides here. Add 2 to both sides. Gather all the terms to one side, and then from there, once you get one side equals 0, you can get a common denominator, and the common denominator would be x plus 2. So we need to multiply top and bottom of this term by x plus 2, and then, you know, when we have the same denominator, we combine the numerators, x minus 1 plus 2 times x plus 2 all over x plus 2. That has to be greater than or equal to 0. So in order to really figure out what x values would make the left side positive or equal to 0, we have to just combine everything to one fraction. So we're gonna distribute the 2 times x plus 2 times 2 all over x plus 2, and then we're gonna get, let me scoot it up here a little bit, x plus 2x is 3x, negative 1 plus 4 is 3. So we see we can factor one more time. 3 times the quantity x plus 1 all over x plus 2 has to be greater than or equal to 0. That's what we're looking for, greater than or equal to 0. So finally we got our fraction reduced as far as we can, and we can identify now that that we have a critical value at negative 1, and we also have a critical value, and let me back up. We have a critical value of negative 1 because negative 1 causes the numerator to be equal to 0. Negative 1 plus 1 is 0. And so the left side, if we replace x with negative 1, would be equal to 0. So that's a good value because that one value right there would cause this entire statement to be true. Well, what about negative 2? Well, if we replace x with negative 2, that would cause the fraction to not exist. So we're not going to include negative 2 in our solution set. But as x on the interval from negative infinity to negative 2 would cause the factor in the numerator, so 3 is always going to be a positive number, so we don't need to worry about that factor. But the factor of x plus 1 on this entire interval, anything to the left of negative 2, replacing x with that, causes the numerator to be negative. And then also the denominator, though, anything to the left of negative 2, negative 3, negative 4, negative 5, would cause the denominator to be negative. And so any real number on this interval would cause the numerator and denominator to both be negative. Therefore, the quotient of those two numbers then would be a positive number. So then we have to try to replace x with any real number in between negative 2 and negative 1. We don't have a convenient one. So let's just think about this logically, like negative 1.5. Let's try that one. Negative 1.5 plus 1 would cause the numerator to be negative, and negative 1.5 plus 2 would cause the denominator to be positive. Therefore, any real number in between these two real numbers would cause the fraction to be negative. And then likewise, anything to the right of negative 1, 10, if we replace x with 10, both the numerator and denominator will be positive. Therefore, we are dividing a positive by a positive, and we know that that's going to be a positive number. So any real number then, we're going to include negative 1. Any real number to the right of negative 1 and including negative 1 would cause this statement to be true. And so that's how we do it. We just look right there at that. We want this fraction to be non-negative, and we would say, therefore, based on what we found, that the solution set would be all real numbers to the left of negative 2, as well as all real numbers to the right and including negative 1, and that is the solution.